Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
What is up, everyone, and welcome to our course on the Python language basics. My name is Nimish, and I'll be guiding you through the next few hours in which we'll be learning the basics of programming in the language Python. By the end, you should know enough to get out there and start developing real Python programs. These tutorials are for those with no Python experience. If you have coded in Python before, likely you know enough that you may find these tutorials to be a bit slow. We're kind of expecting that you know nothing about Python. We also expect that you have little to no programming experience in general. We will be approaching each of these topics from a complete beginner's standpoint. So if you have plenty of programming experience but no Python-specific experience, likely you'll still be able to pick some things up, but you may again find things to be a bit slow. And of course, we're assuming that you do want to learn Python. If you have no interest in the language Python, this is probably the wrong course for you. Now, just a quick side note, I will be recording everything on a Mac. There is actually no operating system requirement for this course because we will be running everything in the browser through Google Colab. Okay, just want to make you guys aware of my operating system just in case things look a little bit different, but it really doesn't matter if you're running on Linux, Mac, or PC, should be fine either way. What are we going to be learning as kind of general topics? We'll start with what makes Python unique. I think it's a good idea to figure out why we want to learn the language that we're going to be learning, so we'll be talking about what makes Python great. Then we'll learn how to keep track of data, typically through various types of variables, arrays, and of course modifying them through operations. Then talk about how to implement logic. This will be done through if statements, while and for loops. Then we'll talk about how to implement responsiveness, and this will be done through the use of functions. And finally, how to create data structures through the use of classes and objects. Now, our specific topics start with, again, an intro to Python. We'll just talk about kind of why you should learn Python and what's it all about. Then go into variables and operators. Then we'll talk about collection types. This will be like lists and dictionaries. Then we talk about conditionals and loops, so if statements, while loops, and for loops. Then move into functions. We'll also introduce parameters and return types. And finally, classes and objects. So basically, all of the topics 2 through 5 will be kind of gearing towards this final one, classes and objects that bring everything together. So how are these tutorials specifically going to be working? Because we'll have some conceptual stuff and some practical stuff mixed in there. Now, most of the topics have a mix of conceptual and practical parts. This is especially useful for those of you who have never programmed before and need kind of an introduction into what the topics are and what each of them bring to programs in general. The conceptual parts will be kind of explained in the slides. For example, if we talk about variables, we'll talk about what they are, how we use them, and even why we would use them in code. And then we'll move to the practical parts, which will be explored through code examples. Again, these will all be run through Google Colab. We'll try to use some real-world examples to make these topics a bit easier to understand. I find that relating the examples back to something that is universal, like game development, for example, is a pretty easy way to understand the topics because game development encompasses basically anything that you could imagine that has to do with programming. And also, most people have played games at some point in their life, so it's kind of easy to relate to examples. Okay, and the final goal is to get you up to speed with the Python basics so that you can start programming as soon as possible. This means we won't be able to cover everything that's in the Python language because honestly, this would be dozens of hours long. Otherwise, there is lots and lots to learn about any programming language. Python is no exception. Our goal here is to teach you the basics, give you some practical examples, and give you enough knowledge so that you can get out there and start programming as soon as possible. Okay, so I hope you guys are super excited about this course. I'm really excited to teach you. I love programming in Python. It's definitely one of my favorite languages. So let's go ahead and get started. Again, thanks for signing up, and we'll see you guys in the first section. What's up guys, welcome to the first tutorial in our Python Language Basics course. This is an intro to Python and will give us a chance to take a few minutes to learn about what Python has to offer us as the programmers. For starters, we're going to be talking about what is Python. Then we'll move to what are some of the applications of Python, or where do we see it out in the real world. Then we'll talk about what makes Python unique compared to other similar languages. And then finally finish up with why learn Python. For starters, Python is a high-level, general-purpose, interpreted programming language. Now, I don't expect you to understand all of what that means, but generally speaking, this means that it is kind of easy to read and write as being a high-level language. General purpose means that it is applied to many different domains, and interpreted is just kind of a programming style. It's considered to be imperative, object-oriented, functional, and reflective. Again, these are other ways to describe how the code can be written within a Python program. Don't expect you to completely understand what that means, but just thought I'd put it out there as an interesting piece of information. It was first introduced in 1991 by Guido van Rossum. I hope I'm saying his name right. The last stable release was version 3.8.1 at the end of 2019. That's kind of when I'm making these tutorials, end of 2019, beginning of 2020. So likely you may have a more recent version when you're taking this course. Now, what are some of the applications of Python? Well, Python actually is applied almost everywhere, from desktop programs to web development with the Flask framework. And finally, into game development with Pygame. You'll see Python in pretty much all domains except for mobile. So far, there isn't really a good framework for mobile development with Python. You'll often see Python used in data science, particularly in machine learning programs. I think it's by far the most commonly used programming language for those kinds of applications. Now, what makes Python unique compared to other comparable languages? Python's unique syntax does away with brackets and uses indentation instead. That is by far one of the most prominent features of the Python language. Most other languages, at least that I have used personally, use curly brackets to encompass code blocks. Python doesn't really use those. It just focuses on using indentation to determine which piece of code belong to which code blocks. Python uses dynamically typed variables. That is kind of the next biggest feature that people tend to notice. Dynamically typed variables are variables that can hold many different kinds of data. This is compared to statically typed variables that are only able to hold a single type of data. So this makes Python very, very flexible, but also kind of introduces the need for extra error checking and stuff. So Python becomes very flexible due to the dynamic type, but that also kind of slows down the runtime very slightly. If you were to run the same Python code and maybe the same C++ code, C++ code will almost always run a bit faster. That said, C++ is known for its efficiency, and it's also much harder to program in, so it's kind of an unfair comparison. Another thing about Python that makes it unique is that the code is executed line by line rather than all at once. Okay, so some of the programming languages, they'll kind of execute an entire block of code all at once. They'll do all the error checking and stuff then. Whereas with Python, we do things line by line, kind of only encountering problems when we reach them. Now, why go about learning Python at all? Well, there's lots of reasons. For starters, Python is expressive, which makes it very easy to read and write. This is excellent news for those of you who are completely new to programming, because having to learn this complex syntax on top of these complex programming principles is kind of too many things at once for some people. Python has a ton of great frameworks and libraries out there. We saw that in the application slide. There are lots of these different frameworks that help us to apply Python to various domains. There are tons of support forums. It's by far one of the most popular programming languages out there, which means there are a ton of people who want to answer questions, a ton of people asking questions in the first place, and so on and so forth. Python is one of the most in-demand languages, especially when it comes to data science. Everyone, it seems, wants to either be a data scientist or wants data scientists on their teams, and Python is one of the most widely used languages in data science. So if that's at all of interest to you, Python is a key language to learn. Alright, so hopefully you're excited and convinced that Python is a language that you want. I think it's by far one of my most favorite languages to program in. It's super easy, super flexible, and you can basically get a program up and running with almost no work. Okay, so that is it for our intro to Python. In the next section, we're going to be starting our actual language basics, learning about some of the different kind of programming principles. We'll start with variables, so stay tuned for that. Thanks for watching. See you guys in the next one. What's up everyone? Welcome to the second tutorial in our Python language basics. Here we'll provide an intro into variables. We're going to spend some time in the slides learning about what variables are and how we can use them in Python. What we'll be covering here. First, we'll give a general intro into what variables are and what they do for us in the sense of a program. We'll talk about what types of variable Python has and go over what each type will represent within a program. And then finally, we'll go over some quick examples. Now, we'll be spending our time in this tutorial in the slides. In the next tutorial, we're going to turn over to Google Colab and take a look at some real code examples. Okay, so keep that in mind. If you know exactly what variables are and what types are available in Python, feel free to skip this section. Otherwise, definitely stick around. For starters, what are variables and what do they do for us in the sense of a program? Well, variables simply act as placeholders for data. So they store values that can change throughout the program's execution. Essentially, we use these to store the state of a program as it runs. So for example, we might use variables to keep track of a player name, maybe a date, how many lives they have if they're playing a game, so on and so forth. So any data that we need to store will be done so in variables. Variables typically have a name, a type, and a value. Now, we can also assign the value of none if there's no specific value we want to associate with a variable. None is basically the equivalent of nil or null in other languages, just means a variable has no value. Otherwise, each variable will have a value based on the type of variable that we're dealing with. So let's get into the kinds of variable types available, and for starters, what are variable types? Variable types dictate the kind of data that a variable can hold. For example, are we dealing with numerical data, or is it going to be, let's say, like true or false data, or maybe text data? These are going to be dictated by the type of variable. Interestingly enough, Python is considered dynamically typed, which means that the types are very flexible and can change. This is not the case in, I'd say, most programming languages. Most programming languages are statically typed, which means once we assign a type, let's say a string or an int, whatever, to a variable, that cannot change. Not the case in Python. We can actually go maybe from text data to numerical data to true or false data at will. Okay, so this is one of the things that slows Python down a little bit, but it also helps make Python very, very flexible and easy to use. We can actually create custom types through the use of classes and objects, so that essentially expands the types available to an infinite number. But more on that once we talk about classes and objects. That'll be the final topic in our language basics. For now, we'll just be dealing with the basic types available in the standard Python library. We can also convert between most types as long as it makes sense. For example, if we're taking a numerical data, we can definitely turn that into text data. We can even turn it into true or false data. But let's say we have some text that's a name, maybe my name Nimish. It doesn't really make much sense to turn that into a number. Now, the standard library types we'll see in Python will be bools or booleans, floats, ints or integers, and strings. We'll take some time in the slides to kind of go over each of these types, what they represent, and how we'd use them in code. I should say before moving forwards, when we're assigning a value to a variable in Python specifically, that's what dictates the type. Okay, we usually don't explicitly assign a type to a variable. That's definitely something you do in other languages, not so the case in Python. We basically take a variable, assign it a value, and then that automatically assigns the type. Okay, so let's talk about Booleans first, because these are by far the easiest and most simple data type. These are just a true or false representation of data, so they can basically take on one of two states. If they're not true, they're false, and if they're not false, then they're true. So it's either kind of one of the two. We can think about this as being binary. A binary state is something that's either essentially a 1 or a 0. It's either one state or it's the other, and it cannot be anything else. And so a good use for these will be when a variable can take on only one of two states, such as, let's say, an on or off switch. So if we're turning a light on, it's either on or it's off. I can't really be in the middle. I guess you could say if you attach a dimmer switch, then it's only kind of on, but realistically that's still on. So essentially we're using variables like Booleans when there's only two possible states. These often store the results of the comparison operation as well. So let's say we're comparing two numbers. Is number 1 greater than number 2? If it's true or false, that will be stored in a Boolean variable as well. And so we'll often use these along with control flow to kind of dictate the flow of code or which parts of the code we want to execute. Okay, next up we have ints and floats. These are both numerical data. But the difference between them is that integers are whole numbers, whereas floats are decimal numbers. Now this becomes kind of interesting in Python where we're not specifically assigning a type, because if we assign, let's say, the value of 1 to a variable, then that will take on an integer type. But if we did 1.0, then it takes on a float type. And so it can be beneficial to explicitly assign a type sometimes, otherwise we kind of just let the compiler sort that out for us. Now I should say there's also no native double type in Python. There are some libraries that have doubles such as NumPy or Pandas, but we'll be dealing only with floats in native Python, okay? Doubles are something that exists in other languages. It's essentially another representation of a decimal number that has more precision, more decimal points, but not really something we deal with in Python. And finally, we have strings. So strings are by far the most interesting. They're used to represent text data. I say interesting because they're flexible. They can be basically any value between the double quotes or the single quotes. There's no distinction between these two in Python, as long as you're not combining them, say like one single, one double quote. It has to be both double or both single. In some languages, single quotes are used for just characters. I'm thinking specifically about Java or Swift, but not really the case in Python. It doesn't matter. So we use strings for names, messages, text data, basically anything that we're not going to be able to use a numerical type or a Boolean type to represent. But that being said, we can also use strings to contain text representations of numbers or true or false values. This will be very beneficial sometimes where we don't want, let's say, an integer or float type, but we do still want a number. Okay, we can use strings to represent that, same with true or false values. It should be said that we can convert... What's up guys, welcome to the third tutorial in our Python language basics. Here we're going to continue on with where we left off last time, talking about variables, but we're going to go over some examples of variables in action in Google Colab. So we're going to start just by creating different types of variables in Python so that we can get used to creating variables and assigning values and also determining the type of variables if for whatever reason we're not sure. This is a cornerstone to programming, so it's important that we get this down. We're going to start by working with Booleans or bool, integers or int, floats or float, and strings or string or str. So in the parentheses there, you can see the type as it would appear in Python. We'll basically just create some variables of each. We'll print out the value, print out the type, and so on and so forth. So let's turn on over to Google Colab and get started. So here you can see I've got a Google Colab notebook started up. I've called this one Python Language Basics, IPYNB. I would recommend that you get one started up yourself now or start up some other kind of Python environment where you can write and run Python code. Okay, good. So I'm assuming that you have your environment set up and can begin writing code. So I'm just going to zoom in a bit there. All right. So the very first thing we might want to do is create a Boolean variable. Before we even do that, let's talk about how to create variables in Python. So some languages will require you to do like a variable or a constant or something like that. That's not even necessary in Python. We just need a name and a value. Okay, it's as simple as that. We don't even have to assign the type. That is interpreted automatically by the compiler, although we can explicitly assign a type if we really want. Okay, so in, let's say in Python, the naming convention is typically to do if you have like two names for a variable. So we had some variable. Some languages will do this. In Python, it's better naming convention to do this. So separate your words with an underscore. It doesn't really matter too much. You can do camel case like this if you really want, but it's kind of better practice to do that in Python. It's a more accepted naming convention. Okay, cool stuff. So let's create a Boolean variable. Where might we see Booleans out in, let's say, a game? It's because I think for the examples, I'm going to stick with game development. Well, how about the most simple one, to determine if the game is running or not? Okay, so we might have some kind of condition, some variable that we're using to keep track of to tell if the game is over. So we can do something like is game over is going to be equal to false, or it's going to be equal to true. Okay, so let's set it as a false for now. And let's say we want to print out this value. Printing things out in Python is super easy. You just do the print, you call upon print function, and you put whatever you want to print between these parentheses. So we're going to do is game over. Okay, so let's go ahead and run that. Okay, it's just going to take a second. I'm just going to pause this, wait for it to finish. Okay, and it's finished running. It only took a few seconds, and you can see that's printed out false. That makes sense. We assign the value of false to the variable is game over using this assignment, and we're just printing it out. We can then print out, or rather reassign it and print it out later again. So we can say is game over is now going to be equal to true. Okay, we'll go ahead and print it out. Okay, and we'll run this again. Oops, we don't even really need to save it. We'll just go ahead and run the cell. So first we get false and then we get true. Makes sense because it was false here and we printed the value out. But then we changed it to be true and then we printed its new value. So each time we change the value, that is going to be the value it takes on throughout the rest of the code unless we change it again. Okay. Also, we can do something like is game over is equal to 5 greater than 6. Okay, what do you think this is going to be? Well, this should be false because 5 is not greater than 6. So let's go ahead and print it out once more. Okay, makes sense. We get false printed out there because we've taken on the value of a false assertion. So it's going to be false. Okay, so Boolean's fairly straightforward, just true or false values. Let's go ahead and create a new cell and let's talk about numerical data types. So again, these are going to be integers and floats. Integers are whole numbers, floats are decimal numbers. So where might we see these in code? Well, we might keep track of the number of lives something has. Those have to be whole numbers. We can't have like part of a life. Doesn't really make too much sense. So let's have a variable called number of lives, or num lives for short. And let's say we start out with 5 lives. Okay, we want to go ahead and print out num lives. We can. Let's go ahead and just run that cell there. And we should see 5 being printed out. Okay, so what about decimal numbers? Well, maybe we'll use decimal numbers to represent some kind of stat. So this could be maybe health, or it could be attack or defense. Realistically, in a real game, we'd probably use whole numbers for these, but let's just pretend that we would use decimal numbers, and let's just say something, you know what, maybe percent health makes a bit more sense. So we'll do like percent health, and we'll say it's going to be maybe 0.5, that represents 50% of our health bar. Okay, so then we go ahead and print out percent health. We can do so. Let's go ahead and run that cell. So we're printing out number of lives and then percent health there. So you can see 0.5. Again, important to note that this is assigned a whole number, so it's an integer type. This is assigned a decimal number, so it is a float type by default. I'll show you towards the end of this tutorial how to determine what the type of a variable is, but for now, let's cover strings and then we can get to that. So let's open up a new editor, or rather a new cell. Okay, so what about strings? We know that's anything between the double quotes here or the single quotes. Again, it doesn't really matter in Python, but you can't have one of each. You couldn't do this like that. That doesn't really make any sense. Okay, so what would we use a string for in a game? Well, how about any message we're printing to the screen, or we can go even simpler. What about a player name? Okay, or even a character's name. For that, we should probably use a string. So I'm just going to say something like player name is going to be equal to, and then you can put your name there. I'll just put mine. Nimish, that's fine. I should note that this is not equivalent to this. These are very slightly different characters, the upper and lower case. Just want to point that out. Okay, so just like with integers and Booleans and floats, we can reassign values. So I can maybe say my player name later on, I'm changing players, is going to be equal to, I don't know, mammoth or something like that. Okay, that's totally legitimate. Again, we can just print out the player name, see how it changes. Let's just copy that and we'll paste it in there. Okay, and you should see again the value changing as it does. Okay, and I guess just to demonstrate that we can use single quotes as well, I think I'll do that. We can paste it in there, and the cell should run just like before, no problems whatsoever there. Okay, so again, text, names, messages, etc., anything that's text related. All right, so the last thing I wanted to talk about is determining the type of a variable, and this is through the typeof function. Or actually in Python, it's actually just type. Okay, so most of the standard library stuff will turn a specific color. You see that this is part of a standard library, the print function. These are all particular primitive values. Type function is in blue, so it's not actually, in some languages it's typeof. Python is actually just type. So we can put type and then the name of the variable we're trying to determine. So we have Booleans, integers, floats, and strings. Let's do one of each. So we can do is game over. Okay, and I'm just going to copy and paste that 4 times. Oh, actually, you know what? We should wrap these each in a print. So I'm just going to take that and do print, and there we go. Okay, so that will ensure that we're actually printing out the value each time. Okay, so we'll start with is game over. Then we can do number of lives and % health. So num lives. Then we'll do % health. Okay, and then finally the player name. Okay, good stuff. So let's go ahead and we'll just print that out. Just close that up. And you can see that these are class bool, int, float, and string. So just like I put in the parentheses, this is kind of the type of each of these. Okay. We'll talk about how to convert back and forth between types in the next section. But I just want to note that types are dynamic in Python. That's something that we talked about in the slides. So what if we do this? What if I said that the number of lives is now actually equal to some string representation of that number? So it's actually a string 5 rather than just the number 5. Well, now when I print out the type of number of lives, okay, I go to rerun the cell. Okay, so we get bool, int, float, string. That's good. That's what we expect. But now we get a string. So even though we first assigned it a numerical type, an integer, because we changed it to a different type of literal value, we're now also we're now seeing it change type to a string as well. Also, one final thing I should mention, I don't think we've covered this yet, we can actually reassign a value of another variable. So for example, if I wanted to say for whatever reason my new player name is going to be equal to the number of lives, I totally can. I can say something like player name is going to be equal to number of lives. It doesn't really make much sense in our context, but you can totally do that. It doesn't just have to be a literal value each time. We can reassign a variable value too. Okay, so that is it for now. What I'd recommend you do, because again, practicing and doing stuff yourself is the best way to learn coding, is to try some examples. So create maybe another variable of each type, another Boolean variable, a integer, a float, and a string variable. Maybe try printing them out, seeing what the types are. Try reassigning some values to them, literal and other variables. Again, keep printing out those types until you get really familiar with that. Once you're ready to move on, we'll talk about type conversion. Okay, so thanks for watching. We'll see you guys in the next one. What's up, guys? Welcome to the 4th tutorial in our Python language basics. Here we're going to focus on type conversion. This is conversing back and forth between variable types, and we're going to launch straight into some examples. Now we'll start by talking about some specific examples of conversing between different variable types. We'll go over kind of what is and isn't allowed, because for the most part these conversions make sense, but sometimes they're just plain weird. So that's where these kind of interesting tricks, I'm not sure tricks is the right word, maybe subtle nuances that are built into Python come into play. So let's head on over there now, and we can kind of continue on where we left off last time. As you can see, I've just added some small annotations, and let's go ahead and get started. Okay, so we'll want a new cell here. Just going to zoom in so you guys can read it a little more easily. And seeing as we have variables of all types, I figure we can kind of go from here. So we have some bools, ints, floats, and strings. I think actually we converted that int to a string just for that demonstration. So the first thing we want to do is just convert that back to an integer. Okay, cool. So what I figured we'd do is we would print out the corresponding value of these types after their conversion. Now, I don't think there's much point demonstrating converting stuff to a string. You know what? Why not? We'll go ahead and do that anyway. Basically, to convert anything to a string, you just do string like this, and then what you want to convert to a string. Okay, so let's say, for example, I want to convert my number of lives to a string, and I want to print that out. Okay, I can do that. That's no problem. And it just prints out 5. So this looks exactly the same as if I just printed out 5, but this is a string type. So for example, if I printed out the type of this, okay, then you should see a string. Okay, so it starts out as an integer. Now we're basically converting that to a string. Now one of the big differences here between me doing this and then doing this, number of lives is equal to 5, is that number of lives remains unchanged. Okay, so just to demonstrate that, I'll do something like this. We'll do string num lives is going to be equal to basically this. Okay, and then I'm going to print out the type of number of lives. Okay, and then I'm going to print out the type of string number of lives. Like that. Okay, so one's an integer and one's a string, even though when I print them out, they both look the same. Okay, and that is because this conversion here is converting the value stored here and storing it in this new variable. Okay, so it's actually leaving the number of lives untouched. Okay, number of lives is still an integer. It's basically taking whatever value it finds here, converting that to a string, and then storing that back into the string number of lives. Okay, so that's really the difference between that and if I did number of lives is equal to 5, because this right here is changing whatever value is stored in this variable. Okay, so if then I did that, they should both be strings. Okay, so hopefully you can kind of understand the difference there. I'm actually going to comment that out, and we'll continue on with that. Okay, so just make it known that anything can be converted to a string. Again, you just do string and then whatever we want. Booleans, ints, floats, other strings for whatever reason. But yeah, it just basically prints out the exact string translation. So converting to a string isn't particularly interesting. Let's focus on the others. What about converting to a Boolean? Now, this is where things get really weird, because basically a 0 in kind of terms of a Boolean is considered a false, and a 1 is considered a true. Okay, so that's typical binary. 1 is kind of on, or it's true, and 0 is off, or it's false. Okay, so that makes sense. We do a 1, it's true, 0, it's a false. But outside of that, everything else evaluates to true somehow. Okay, so even if we're converting some random string to a Boolean, it'll be true. Even if we're converting 0.1 to a Boolean, it's true. Okay, anything other than the exact value of 0 is false. It's true, rather. Okay, 0 is a false, everything else is true. Okay, so let's go ahead and print out an example of that. So if I print out the Boolean conversion of a 0, okay, and then I print out the Boolean conversion of a 1, okay, and we'll just demonstrate that, we should get false and true. So that does make sense, actually. A lot of languages will kind of perform a similar process. What if I do a 2? Okay, again, that's true. What if I do a 0.1? Okay, that's still a true. Even though there's a 0, it's still considered a true. Okay, same with if I did some kind of a string. So I can put whatever string I want in here. Okay, and that's also going to evaluate to true. All right, so anything that is not exactly a 0, when converted to a Boolean, will give true, otherwise we're given false. Okay, so what about converting stuff to integers? Now, I shouldn't say most, some conversions are allowed. Actually, most conversions are not allowed. So let's take some random string, okay, and I'll convert it to an int. And let's say I want to convert, again, just some random string to an integer. And let's see what happens there. Okay, now this is not even giving me some unexpected value. This is actually crashing my whole program. Okay, and that's because it's saying we don't know how to convert this to an integer. Okay, it's kind of interesting that this occurs because in a lot of languages these would also give crashes. If it's not a 0 or a 1 or a true or false, then there's something wrong there. But in Python it allows that, but it doesn't allow this, okay? Because it's just so far from what makes sense that it says we don't know what to do with it, we're going to crash the program, okay? However, if I did, I guess I should comment that out because it's not allowed. If I did an integer of a string that's like a 1 or something, okay, that's totally fine. So as long as I have numbers in here, that's okay. As soon as I have something else weird, that doesn't really work so much, okay? I can also convert a float to an integer. So let's say I did a 0.5. I can do that. And in this case, it'll just give me a 0. So essentially, it doesn't round up. It just chops off the decimal place and gives whatever whole number I have here. Okay, so just gets rid of that. Gives the whole number. I know some languages will round up or down accordingly, but not the case with Python. All right. And let's see if I try to do like an integer of a false literal value. Okay, let's just get rid of that. We actually get a 0. So that does make sense. Same with if we did a true, then that should give us a 1. Okay, just like conversing between numbers and booleans, booleans and numbers, it kind of gives a similar sort of thing. Okay, so ints do make sense for the most part. Again, we can do string representations of numbers, but we cannot do string representations of anything else. All right, so finally on to floats. I don't think there's a whole lot more to say about floats. I guess we can actually just kind of run these in the same cells as the integers, because for the most part it kind of works out to be, you know what, actually we'll do a new cell. It kind of works out to be the same stuff. I guess we can just kind of run through some examples of these, but converted to floats. So we'll just replace the int with a float there, and we can go ahead and print out the results and see what we get there. Okay, so we get 1.0. Note that it does actually add the decimal number. If we're converting anything to a float, even if it's a whole number, actually I guess this, let's try a whole number, let's try a 5. It should stick a 0.0 on the end of it. Okay, same with the booleans, false and true. It is still giving us a 0 and 1, but it will always stick a 0.0 onto the end of it. That's kind of Python's way of letting us know that, yes, we're dealing with a float and not an integer, and we need to make that distinction. Okay, so that is actually pretty much all I wanted to cover there. There were just a couple of weird points that, especially if you're coming from other languages, are different in Python. Some things that do and don't make sense. For example, the first time, I guess when I was just starting out with Python, this whole idea of converting strings into booleans that are not true or false. Well, actually, you know what? I never demonstrated this. If we convert boolean of, let's say we want to convert this, okay, that still evaluates to true. Even though this is clearly false, it still gives true. So there were a couple things in the Boolean side of things that really didn't make much sense. This kind of trying to convert text, letters, and other characters to numbers also makes sense, but I'm not sure if that's necessarily intuitive or not. Either way, I just wanted to kind of highlight what is and isn't allowed. Remember, with each of these conversions, doesn't matter what type, or rather from what type or to what type, we're actually not modifying the original variable's value. Okay? All we're doing there is taking whatever value we hold, converting it and storing it in a new variable, or in our case, we were simply printing it out. So the original variable or the original value remains unchanged. Okay, that is different from reassigning a different type of variable. All right, so keep that in mind. In the next section, we're going to be talking about operations. I think we've got some slides on that so we can talk about what operations we'll be using and how we'll be using them. Once we're familiar with that, then we can do the same thing, turn to the code for some examples. Okay, so thanks for watching. We'll see you guys in the next one. What's up everyone, welcome to the 5th tutorial in our Python language basics. Here we're going to focus on some operators and the corresponding operations. Just keep in mind we'll be focusing on the most commonly used ones. There are many more operators out there, but these are going to be the ones that we'll find in our day-to-day coding. So we'll start by covering what are operators in general. Then we'll take a look at arithmetic operators, assignment operators, comparison operators, and logical operators. There are also some other weird operators. We'll kind of group these into the others category. There are even further operators outside of this, which I find myself almost never using. Those are kind of like bitwise and binary operators, but more on that once we get there. Okay, so for starters, what are operators? What do they do for us from a programming standpoint? Well, operators enable us to perform various operations on variables. That makes sense, fairly intuitive. A few of the operators actually modify the original variable value, but most of them don't. Okay, so it's important to note that distinction, that some of the operators will change the original value. Okay, so if you have a variable, just some integer, okay, and I perform an operation, some of them will modify the original integer, some of them will actually just produce a new result, leaving the original variable untouched. Okay, very important to know what does and doesn't occur there. Now, operators can generally be strung together, but they always follow the order of operations and then from left to right. Generally speaking, even though it follows order of operations, it's probably good practice to put your operations in brackets if you want to kind of clearly communicate to anyone reading your code, I want this first, then this, and so on and so forth, okay? So even if we do like a plus operator and add 2 numbers, we can add like 50 numbers if we really want, kind of string that all out. Okay, so the first category are going to be arithmetic operators. These are probably the most intuitive. These are going to be used usually for numerical calculations, although there are other uses. They can also be used to glue strings together. This is often called string concatenation. There are also built-in functions to help us to do this. Strings do have a lot of extra functionality associated with them, but generally speaking, this is just easier to do. They produce a new numerical or string result. They usually leave the original numbers untouched. Okay, and these are going to be our basic arithmetic operators. So addition, subtraction, multiplication, and division. The % sign there is the modulus operator that essentially returns the remainder of a division. That double / is the floor division operator, and it basically performs the division and discards any remainder. Okay, so kind of does the opposite of the modulus. And finally, we have the exponentiation operator, that double star right there. Next up, assignment operators. Assignment operators are used to assign values to variables. In fact, we've been using this repeatedly, maybe without even realizing it. These can also be used in combination with the arithmetic operators. Okay, and these are going to be, first of all, our equal sign. So we've seen that in use many times. It just takes a variable on the left and assigns a value on the right. But there are also these combinations. So any of the arithmetic operators can be combined with this assignment operator. Don't worry, I will explain exactly what the difference is between this and the arithmetic when we get to this in the code section. Next up, comparison operators. Comparison operators are used to compare 2 values. We've seen one example of that with the greater than, or yeah, I think we did the greater than comparison. These can be numerical, string, or even Boolean variables. So we can test equality between them. We can test see if one is greater than or less than the other, and so on and so forth. So these will start off with our is equals. Note the double equals in a row. Okay, that's a comparison, not an assignment. Okay, we have the not equals. We have the greater than or equals to, and less than or equals to. Next up, logical operators. Logical operators are used to test additional conditions. Okay, so these are typically used on Booleans, and these are our not, or, an and. We're going to take a look at an example of not, but or an you know what, we'll probably take a look at an example of all of these, but we will see that these will be much more useful when talking about control flow. All right, so we'll briefly touch on these, but we'll dive a bit more into them in the control flow section, which is a few topics from now. Okay, and finally we have the other operators. So our first operator, the ternary operator, is the if-else operator. So this is a good way to kind of shorten up if statements. If we're going to use them, it basically tests some condition and provides an answer, or I guess actually in this case, it provides a value, and then it tests if something is equal to whatever, maybe greater than, true, false, etc., and then provides an alternative value. Now don't worry, I know that's kind of a bit confusing just hearing me talk about it. We may or may not see that in action, but probably closer to the conditional or control flow tutorials. We'll talk more about the ternary operator then. Okay, there's the identity operator, is or is not. These are used to test membership to a particular class. There's a membership in or not in. These are used to test whether something is in some kind of a collection type. And there are the bitwise operators. These are used to kind of do logical kind of comparisons. We can shift stuff left and right, like by certain numbers of bits. We can AND, OR, XOR, NOR stuff together. Don't worry, I know that's kind of confusing. I very, very rarely find myself using bitwise operators unless maybe I'm dealing with graphics, so we're not going to be covering those. In fact, for the most part, we won't be covering these other operators in these upcoming tutorials. I just figured I'd throw them out there just in case some of you say, well, actually, there are all these other operators. Why are we not including those? I just figured we're probably not going to go over too many examples because they're a bit beyond the scope of this course. Remember, this is really just a beginner's course, Intro to Python. Okay, so that is it for now. Those are the groups of operators we're going to be covering. In the next section, we'll be taking a look at some examples of those. We may split it into two depending on how long it runs. And yeah, so stay tuned for that. Thanks for watching. See you guys in the next one. What is up, everyone, and welcome to our course on Pyplot. My name is Nimish, and I'll be guiding you through the next hour or two, in which we'll be exploring the Python library, Pyplot, and learning how to use it to graph data. For starters, let's talk about who should be taking these tutorials and who shouldn't. Well, we do want you to have some Python experience. That's not to say that you need to be an expert with many years or anything like that. We just expect that you understand the fundamentals, such as variables, loops, if statements, functions, etc. We also expect that you don't have much experience graphing with Python. Specifically, if you have experience with Matplot library or Pyplot, then you may find these tutorials a little bit elementary. We will be approaching these as if you know nothing about Pyplot from a complete beginner's standpoint. Now, just a quick side note, there is no OS requirement. It doesn't matter if you're using Mac, PC, or Linux. I personally record these tutorials on a Mac, and I use Google Colab to write my code. If you don't like the Google Colab environment, that is totally fine. Feel free to use whatever you want. If it's text editor and terminal, or an IDE like PyCharm, it doesn't really matter. The code may run a little bit differently, but I'll try to write it in such a way that it should run on any system. I do recommend, if you don't have too much of a problem with it, to use Google Colab, just so that you can follow along a little bit easier. And like I said, there's no OS requirement if you're running that, seeing as it's all run in the browser. Let's talk about the general learning objectives, or broad speaking, what we're going to be learning here. First, we'll talk about what makes Pyplot so great. This will be just kind of an intro into Pyplot itself. Then we'll learn how to graph various datasets with Pyplot using various techniques. We'll learn how to customize our graphs. This will be stuff like customizing the appearance or adding labels. And then we'll talk about what kinds of graphs are available in Pyplot. Pyplot is a very big library that is a subset of an even bigger library, so there are many kinds of graphs and charts available. We won't go over all of them, but we'll talk about some of the more commonly used types. Right, let's talk about specific topics breakdown so that we can kind of divide our whole course into these subtopics. First will be an intro to Pyplot. Once again, this will be just kind of talking about the library itself, how it's used, and where it might be used in the real world. We'll learn how to install Pyplot. That will be very, very short. It's fairly easy to obtain. We'll learn how to graph some data. So we'll start off fairly simple, just kind of creating a basic line or scatter plot, and then we can move on to some more complex techniques. We'll learn how to customize a graph. So this will be the appearance of the graph, changing the line appearance, or how the points appear on the graph, and then again adding stuff like the axes, labels, and a title. We'll learn how to show multiple graphs in a single figure, so we can lay graphs out side by side, or add multiple data sets to a single plot. We'll cover various kinds of graphs. I think for the most part, we'll keep things fairly simple. We'll probably go over basic scatter and line plots first, and then we can get into pie and bar charts and finish up with histograms. And finally, we'll finish off with 3D graphs. Now, just a quick heads up here. There is still lots more that exists in Pyplot than what we'll be covering in this tutorial. This is really just aimed at beginners and getting you up to speed with Pyplot as quickly as possible. We don't really have too much time to go over every aspect of Pyplot, but this will cover the fundamentals and should give you a broad enough understanding that you can then expand upon that on your own time. Right, so just a quick intro to how the tutorials will work so that you know what to expect from this course. Now, most of the topics in this particular course are practical. There's a couple of conceptual topics. The conceptual parts will be gone over in the slides, and the practical parts will be explored through code examples. Again, we're going to be using Google Colab to write that code, although you don't really have to if you don't want to. But the key takeaway here is that we'll be focusing much more on the practical side of things and going through actually kind of like a follow-along style coding rather than spending too much time in the slides. I just think this is not really very useful for this particular course. Now, the datasets that we'll be using will be made up for the most part. Feel free to import your own data if you really want, but I'm just going to be kind of generating random numbers probably because, again, not too focused on the data analysis portion in this course. It's really just to show you how to graph data and kind of how to customize it, various techniques. Okay, so that's it for here. Again, thanks for taking this course. I'm really excited to teach it to you guys. Pyplot is a fantastic library. We're going to get started here by talking about a general intro into Pyplot. So thanks for watching. We'll see you guys in that first section. What's up, guys? Welcome to the first tutorial in our Pyplot course. This will be a general intro into Pyplot, and here we'll just take a couple of minutes to learn about what makes Pyplot so special and kind of introduce the library itself. Right, so here we'll first go over what is Pyplot, then we'll talk about some of the applications of Pyplot, places where you might see this in the real world or in real programs, and then we'll go over what we can actually do with Pyplot specifically. For starters, what is Pyplot? Well, Pyplot is actually a sub-library within the big library, Matplot library, that allows Matplot library to work kind of like MATLAB. If you've ever used MATLAB before, you should know that graphing is pretty easy. Basically, the graphs are treated as figures, and so the idea behind Pyplot is that we can kind of introduce that sort of interface, that sort of functionality into Matplot library. Now, that might not mean too much to you, but essentially what this means for us is it allows users to treat graphs as figures, which can be implicitly and automatically created. Pyplot is very, very intelligent in that we basically just feed it some data and it does most of the heavy lifting for us in terms of adjusting axes, actually plotting the data, etc. So this allows for very easy graphing of data. It's extremely user-friendly. You basically just toss some datasets into a plot function and it does all the work for us. It's open source, so if you notice any bugs or have any suggestions, then you yourselves can actually suggest edits in the GitLab repo. And as of the time of my recording, the latest version is 3.1.3. Depending on when you're taking this course, you might have a much later version. I just want to point that out right now so that you don't take this course and say, oh, well, that's obsolete because you're using incorrect functions and stuff. The stuff that I'll be going over will be specific to 3.1.3. All right, so where might we see Pyplot used out in the real world? Well, anytime we need to create graphs and charts with Python, Pyplot is likely going to be the library used there. So that means it's often used in data science and analysis programs. So any kind of data analysis, anytime we need to graph data and analyze it, then likely we'll use Pyplot. It's great for recognizing trends in data. This can be particularly useful if you are creating models that are based on trends such as weather prediction or stock market prediction, stuff like that. It's used very commonly in machine learning to kind of measure, for example, how well the model is doing, stuff like loss, accuracy, etc. We often plot that data over time to kind of get a sense for how well our model is actually performing. And it's often used for image viewing and analysis as well. There are actually functions within Pyplot that will help us to better analyze image. This can be stuff like applying just a red scale or green scale or blue scale to an image, kind of breaking apart the image, modifying it, etc. Pyplot is commonly used for that too. Now, what can we specifically do with Pyplot? Pyplot is going to be used to create like scatter plots, line graphs, etc. It can also be used to create charts such as bar charts, pie charts, and so on and so forth. Again, there are many more kinds of graphs and charts available, but these will be some of the more commonly used ones that you might see. It can also be used to generate 3D graphs, and that's very powerful because that takes actually a lot of kind of processing to process 3 different sets of data. We can customize a graph appearance, line style, axes, titles, etc. It's actually very flexible in this regard. There's a lot that we can do. And we can use it to very easily create trend lines, lines of best fit, etc. by plotting multiple lines on a single graph. So essentially, Pyplot is really all about graphing, or I guess there's a little bit of image analysis in there. There's plenty of options as far as different kinds of graphs or charts, 3D graphs, etc. It's highly customizable. It's just all in all a great library. Okay, that's all we really wanted to cover. There's not much else to say. Anytime you want to be using, anytime you want graphs in Python, Pyplot is probably your best friend. So let's get started in the next section by talking about just an intro into how to plot some basic data with Pyplot. Actually, before that, we'll need to learn how to install it, but that'll be really, really quick. Okay, so stay tuned for that. Thanks for watching. We'll see you guys in the next one. What's up, everyone? Welcome to the second tutorial in our Pyplot course. Here we're going to install Matplot library, which will give us access to Pyplot, which we'll use to graph our data. So we'll start here by covering where to find the package and the documentation. I'll just quickly show you the website, and you can kind of explore the documentation there if you'd like. Then we'll learn how to install Matplot library in Google Colab. If you don't want to install Google Colab, I'll show you how to get the Matplot library through terminal or command prompt for your Windows users. And then finally, we'll talk about how to access Pyplot from within a Python file. So let's head on over to a browser now. All right, so as you can see, I've got Chrome open here. If you want to use a different browser, totally fine. This will just be kind of navigating to the documentation. So I'm just going to search for Matplot library here, matplotlib, one word. And we're going to go to this first site here. This is the official Matplot library web page, or I guess this is kind of the home page. So as you can see, it gives you information on installation, gives you the documentation stuff, there's some examples, some tutorials, etc. Now, for the most part, the tutorials and the examples documentation is okay, much better than a lot of the other documentation for a lot of other languages I've looked at, but it can still be a little bit confusing, hence why I assume you're taking these courses. Our goal, again, is, of course, to make this as easy and user-friendly as possible. So if you want to read through these, that's totally fine. What I'd really recommend you do if you're new to this, though, is watch our tutorials first, because we'll explain the important parts, and then if there's some specific task you want to achieve, then you could maybe turn to the documentation, or just if you want to learn more later on. Okay, so now you know where to find it. We can kind of close that up. We're going to now turn to Google Colab. Google Colab here. We're going to go to, again, this first link if you want to use Google Colab. If you really don't, that's fine. I'll talk about how to kind of do something else in a second. We're going to go ahead and start a new notebook. Okay. And I'm going to rename this to something like Pyplot code or something like that. And interestingly enough, because Google Colab comes with the latest version of Python, or one of the later versions, it will have the most up-to-date version of Matplot library installed with it. In fact, I'm pretty sure when you download any version of Python, it should include that version of Matplot library in it as well. So if you just downloaded Python, you should have Matplot library installed already. If you don't, then Google Colab will have it installed already. Otherwise, we can go to terminal. Okay, and I'll show you how to install it that way. So if we want to install specifically the Matplot library package, open up terminal if you're on Linux or Mac. If you're on Windows, then this will be the command prompt. However, if you are on Windows, just make sure you run the command prompt as an administrator. Okay, good stuff. So Windows and Linux, you'll write the command sudo pip install matplot library, like so. Okay, just provide my password, that's fine. If you're running Windows, you'll basically do the same command, just minus the sudo, because all sudo does is it gives administrative privileges. So Windows users, again, running command prompt as an administrator, it will just be pip install matplot library like so. Okay, so I'll give you access to the whole matplot library, including Pyplot. All right, good stuff. Now back to Google Colab, or if you are not using Google Colab, go ahead and start up a new Python file. In order to gain access to the library, we're going to add the import. So zoom in for you guys. We're going to say from matplot library, import Pyplot as PLT. Okay, so this again is Pyplot is going to be encompassed in matplot library. So this is kind of the overarching library. It has a lot more stuff. We're mostly just interested in Pyplot for now, although I think we will use this right at the very end without Pyplot. But we're basically, for now, just interested in importing Pyplot, and I'm just renaming it to PLT short form. So now if we want to access anything Pyplot related, it'll just be PLT dot, and then whatever we need there. Okay, so include this at the top of any Python file where you need to be using Pyplot. So if you're running Python through just like a text editor or an IDE, be sure to include this line somewhere in the code. Up at the top is probably the right spot for it. If you're running an IPYMB notebook of some sorts, then just kind of add this in its own cell. You can go ahead and run that cell now if you really want. Otherwise, as long as this is good to go, then we're fine here. That's all we wanted to cover. You now know where to find the documentation for Matplot library. You have access to the Matplot library and Pyplot with it. And now you know how to access Pyplot through a Python file. Again, before you go do all of this, we're assuming that you have a version of Python installed, specifically 3 point something. So make sure you have that done. Okay, when we come back, we're going to be learning how to plot a very basic line and scatter plot and just creating some random data to populate it. So, thanks for watching. We'll see you guys in that one. Hey everyone, and welcome to the third tutorial in our Pyplot course. Here we're going to learn how to create a basic line plot, which is the default way of plotting things using Pyplot, and then we're going to put some data on that graph. So the first thing will be to create some random data. You can use whatever data set you want. I'll literally just create about 100 random values, although feel free to import your own data if you want. We're going to then graph the data with Pyplot, and we'll learn how to connect the data points with a line, as well as create just a basic scatter plot. So let's head on over to the code now. Alright, so this is where we left off last time. All we've done is installed matplot library and we've added the import. So now we should be able to use anything that has to do with the Pyplot library. So we'll again just run that cell, making sure we're good to go, and then we'll add in a new cell here. Okay, so all I'm going to do here is I'm going to create 2 arrays of data. I guess in Python they're lists, not arrays, but basically same thing. So the first step is going to be to create some values. All I'm going to do in my case is going to do numbers 1 to 100. This will be our x values. And then for the y values will literally just be 100 random numbers. So feel free to import some real data if you want. Just make sure that you have an equal number of x and y values. You can have as many as you want. You can have 100, you can have 1,000 if you want, or you can work with just a few. It doesn't really matter. The focus here is just getting data and putting it onto a graph. Okay, so in my case, I'm just going to do something really simple. I'm going to say x is equal to an array. We'll say I for I in the range from 1 to 101. Essentially, this is short form of creating a range from 1 to 101, so that's the numbers 1 through to 100. And we're just assigning each of those values to a new value in this array of x, okay? So I don't want to deal with a range. I want specifically a list of values, okay? Hence why I'm putting this in a list in these square brackets. If you want to print this out, all it will do is print out the numbers 1 through 100. Okay, it's just a simple list there. All right, so what about y? Like I said, if you want to use real data, that's fine. But for me, I'm actually just going to create about 100 random values here. So I'm going to say for I in range from 0 to 100, okay, doesn't matter if we do 1 to 101, just as long as it's 100 values. We're going to add some random numbers to y. So for this, I'm actually going to need the random import. So I'm going to import random, which is part of the regular Python library, standard Python library that is. Okay, so and then I'm just going to say y.append, and then I'm going to create a random number. So I can create a random integer by doing random.randint. Okay, so random integer, and then we need to place the lowest possible value, in this case 1, and the highest possible value, in this case 100. So like ranges, 101 is not included in it. Okay, so this is just a range 1 to 100, only including 100. Alright, so all this is doing, it's running 100 times. Each time it generates a new random number between 1 and 100 and adds it to y. So if you want to print out x and y, that's fine. X is just this. Y is just going to be 100 random numbers. Again, use whichever data you want, just as long as you have an equal number of x and y values. Good stuff. Okay, so in my case, I have 100. That's fine. I can go ahead and run the cell. Should be good to go. No outputs, that's fine. And then we'll create up a new cell here. So this dataset will be used throughout the remainder of the tutorial. We may add other datasets in. We may create extra stuff. We may even use some real data, but we'll kind of see once we get to those points. Okay, so let's talk about how to put this data on a graph. Well, there's lots of ways we can do that. The kind of default way of doing things is to do plt.plot. And then all we need to enter here, all we really need to, is the x and the y. So we can enter other arguments if we want. Actually gives you a lot of information here, but we're not going to worry about that. All we'll do is use the default values, default line, color, etc. Okay, and we can go ahead and run that. Okay. Cool stuff. So depending on what your random values come out to be, you may get a slightly different looking graph, but it should still be, again, numbers 1 to 100 and 1 to 100 here. Okay? So again, it might look a little different, might be exactly the same depending on what your numbers are, but essentially it should just be 100 points all connected with a line here. Now, if you're not running through things through some sort of IPYMB notebook, you'll need to also do plt.show, okay? And this will actually show the graph. So the IPYMB notebooks kind of automatically show the output, even if you don't print it out or show it. This is actually the proper way of doing things, is to create the plot and then show it. So we'll be using the show function from now onwards. You can kind of see that we don't actually get the object output as well. All right, so again, the default value, I'm not entering any parameters, anything like that, except for, of course, the x and y, is to create this, to plot the data, connect all of the points sequentially with a blue line, as you can see. Now, it's often going to be the case that we want data on a graph, but we don't want to connect it with a line. Okay, this is great for recognizing how the data changes over time. But what if we want to put, let's say, like a line of best fit through the data, or we want to recognize clusters or some other kind of pattern recognition technique? Well, for that, we can use a basic scatter plot. So I'm actually just going to copy this code over. I'm going to start up a new cell here. Just going to paste it in, and I'm going to replace plot with scatter. So instead of creating a plot and connecting everything with a line, this is just creating a scatter plot, which should just put the points on the graph like this. Okay, so again, exactly the same data set. If you want, you can, if you want to prove that, you can connect all these points with a line, although it's going to take a really long time. But these are the same data sets. It's just these are connected with a line, these are not. So here you could put like a line of best fit through. It should kind of probably be right up the middle. Here you can see that each of the points are connected one after the other with a line. All right, so that is pretty much all we needed to cover here. We did 3 things. We first created a data set. Again, didn't have to do this. You could use whatever data you want. You can manually enter some numbers. That's fine. We learned how to plot, align, graph. So essentially just putting the data points on a line and connecting them all with a graph. That's a default value, a default way of doing things. And then we learned how to create a scatter plot, which is kind of the same thing, just minus the line. It's just the points on the graph. Now, when we come back, we're going to be talking about how to customize these 2 graphs. In fact, a lot of the customizations will be pretty much the same for all of the graph types. This will be doing things such as adding lines, or rather customizing the color of lines, the style of these data points, and adding axes and title labels. Okay, so stay tuned for that. Thanks for watching. We'll see you guys in the next one. What's up, guys? Welcome to the 4th tutorial in our Pyplot course. Here we're going to work on customizing our graphs, and it will be a way to customize how the graphs appear as well as how the data is represented. We'll start by adding titles to the graph and then changing the axes, so just adding axes labels. And finally, we'll finish off with changing the line or the dot appearance of the graphs. So let's head on over to the code now. Alright, this is where we left off last time, number 3. That was just creating some random data and plotting it. So we just created basically 100 random data points. This is what the first iteration of them looked like in a regular line plot and then in a scatter plot. Note how there are no labels here for either the axes or the title, and both of them are this kind of boring, flat default blue. So we're going to work on adding the title and the labels, and then work on changing both the line appearance and the dot appearance. So let's go ahead and get started here with a new cell. It's going to create that. Okay, and let's just zoom in a bit. Okay. So the first thing to do, add again those titles. I'll start just by kind of replotting everything. So I'll do plt.plot x and y, okay? And then again plt.show like this. If we go ahead and run that cell, that's again just going to give us our default plot. Now, one thing to note here, I know that this plot looks different from this one. I mean, it's still that blue, no labels and everything, but note how the data is different. So clearly different y points. Okay, that's just because I had to rerun my kernel because I kind of closed it in between. But and because I reran the kernel, it just generated a new set of y points for me. Okay, so that's just why things look different. Don't worry, nothing really has changed because again, this data doesn't really represent anything anyway. All right, so we want to first add a title to this label. What we're going to do before we do plt.show is do something like plt.title. Okay, and then we're going to put our title in a string here. So let's just say, I don't know, some title. Let's go up top. Okay, we can go ahead and run that, and you can see that's provided a nice little title there. Note that this is a function call. Okay, so you do have to do title and then the title in the brackets here. Make sure not to do plt.title equals, because then that reassigns the function. Okay, and then you kind of have to re-import matplot library Pyplot and kind of run through all these steps again. Okay, so the axes are still unlabeled. We can set those with a plt.x label, okay, and a plt.y label. So obviously this will do the x-axis and the y-axis respectively. So we can just do something like x-title. Let's just do it like x-label here. And we can do y-label. Again, this data doesn't really represent anything, so it's kind of pointless to give a real title to these axes or to the overall title. But realistically, you should be doing this on every graph that you display, obviously with an actual title and actual axes, because otherwise anyone look at your graph, they're not really going to understand what the data represents. Okay, even if you don't care about the appearance, at the very, very least, you should be adding these 3 items. Again, just make sure that it's done before plt.show. Otherwise, the 3 items won't be displayed on the graph. The plt.show shows the plot in its current state. Okay, cool stuff. Now, what about customizing the appearance of the line or the dots? Well, there's a couple ways we can do that, and we'll dive into both of them. I guess we'll start with the easy one. Just going to add in a new cell down here and copy this stuff in. We'll start with the easy one, and that's actually done by passing parameters right into the plot function when we go to run it. Now, there's 2 sets of parameters that we can pass in. One is going to determine the color of the graph, and the other is going to be used to determine how the different points look. So you can see here, they're just kind of regular medium-sized dots. Here, there's no dots, it's just a line. We'll, I guess, first focus on the color, and then we can talk about the line, the dot appearance. Okay, so here I'll give you a quick list of the colors. I'm just going to pause this and write them all down. Okay, here you go. I think this is all of them. There may be more, but I'm pretty sure this is all of them. So we got white, we got red, yellow, green, black, I believe, cyan, which is kind of like a light blue, then there's just blue, and then magenta. So interesting color combo, but that's those are all the colors available. Now, to specify them through our plot, what we're going to do is we're going to open up some quotes after we specify the x and y values, and then we're going to choose one of these here. So let's say we wanted a red plot. We could do that. Okay, you can see that we get a nice red line there. We wanted, let's say, a magenta plot. We do the M, and so on and so forth. Okay, so basically it's just specified one of these color codes, and that will kind of plot the respective color on there. Now, what about the dot appearance? Well, that's done through a similar sort of thing. We basically just specify the code in a string, but there are lots and lots of options to choose from. In fact, I'm again going to pause it and we'll write them all down. Okay, and here we go. So I believe this is all of them. Again, there may be one or two that I'm missing, but there are a whole lot of different ones to choose from. Obviously, I'm not going to run through them all because I think that's pointless. I would recommend that you do, though, just so that you get a feel for what some of them look like and how you can change the appearance of your graph. Okay, we'll go through a couple of examples, though, don't worry. So one thing that we might want is to change these to, let's see what S is, okay? So let's do an S here. Actually, let's get rid of the color. We'll just work on the shape code, so make sure not to include any of these guys. Just use one of these for now. Okay, so a couple things. First, note that we're dealing with squares here. The S is clearly the code for a square dot instead of just a round regular dot. Note that it's gone back to the default color again. That's because we didn't specify a color code. And the third thing to note is that it's got rid of the line. So when we do plot and we add in not just a color but a shape, that actually automatically gets rid of the line unless we do one of these guys. So if we do one of those guys, then the line comes back and that changes the appearance. So let's say we wanted the double dash like this. You can see we get a dash line. We could do dash and dot like so. Okay, and I think that's kind of ugly, but in some graphs that might actually end up looking good. Okay, so these, as far as I know, are the only two that keep the line and just modify the line appearance. All of the others make the graph change to dots, and then it will kind of add those dots in. For example, I think this is a pentagon. You see that these become little pentagons. So I'd recommend that you kind of go through each one, take a look at how they look, and kind of maybe choose your favorite one. Now, I did mention that we can actually combine these. And that is true. Basically, we usually do the color code first and then the shape second, but we do it all in the same string. So I know that's kind of weird and unintuitive. You'd think they would be two separate parameters, but that's just kind of the way that Matplot library works. Okay, so let's say, for example, we wanted some red, let's say hexagons. So we could do RH. And as you can see, that has put the hexagons instead of just the round dots, and they are now red. Okay, so again, I'd recommend that you try different combinations of these things until you get the graph appearance that you really like. All right. Now, the last thing I wanted to show you was this setP function, which basically does something very, very similar to this, but is a bit more kind of explicit in how it's going to, I guess, look. For that, I'm just going to, again, start up a new cell and do plt dot plots. We're going to do X and Y again. Okay, and then we're going to do plt.show. Okay, so before we do plt.show, we're actually going to do plt.setP, okay, like this, and that will take in 3 different arguments. So one will be the line, okay, and then we can add the line style. You saw that actually. Let's just open that guy up again. Line style, you can do so through the quotes, just like before. So you could do like red pentagon or red hexagon, something like that, okay? Just like you did with the quotes. Or you can explicitly set, let's say, a line width and a color. So let's say, first of all, we have to get the line. So interestingly enough, we can retrieve that from plt.plot. We can just say the lines are going to be equal to this. Lines, I say plural because there may be multiple lines on this plot. In this case, there's only one, but there may be multiple. Okay, so plt.setP, we want to pass in the lines that we are plotting. Okay, and then in this case, actually, I'm just going to be explicit and set a line width. Maybe let's do a really thick line just to demonstrate that point. And then we're going to do a color is going to be equal to whatever color we want. Maybe we'll do a nice green. Okay, so color has to be done through these strings. Again, the line width is done through a number, and also we can just do like the line style using these kind of codes like before. Okay, so let's go ahead and we'll run that. So you can see we get a nice thick line. Obviously, this is kind of too thick for this data because it's just too close and everything blends together, but you can see that it works. So we've got a specific line width and a green color, and so there we go. Okay, so that's pretty much all we wanted to cover. Again, I'd really highly recommend that you run through at least a few of these different ones to kind of see how everything is going to look. You might get some very unexpected dot appearances from these. I mean, who knows what 1, 2, 3, and 4 are going to represent. But yeah, so definitely run through those, check out some of the colors, different combinations using set P or just using these color codes. And when you're ready to move on, let's start learning about the next topic. That next topic is going to be plotting multiple lines on a single graph or adding multiple subplots. Okay, so stay tuned for that. Thanks for watching, and we'll see you guys in the next one. What's up everyone, welcome to the 5th tutorial in our Pyplot course. Here we're going to work with multiple graphs and we'll study how to add multiple graphs either to a single plot or as subplots. So we'll start by plotting multiple datasets on a single graph, and then we'll create multiple subplots so that each one is its own separate graph. So let's go ahead and get started. Alright, last time we finished off with customizing our graph by adding title and axes. I know I said that we should always be adding title and axes, but again, just because this is the tutorials and we're focusing on different topics, we're not going to bother doing that for the rest of our graphs, unless of course you really, really want to. So, let's go ahead and get started with a new cell here. Okay. And the first thing that we'll want to do is learn how to add multiple plots, or multiple data sets rather, to a single plot. You'll very often want to do this if you're comparing two sets of data, so you don't necessarily want them side by side, you want them both mapped onto the same plot so that you get that direct comparison. Now for this, we're going to create two different sets of data. I have some random values here, but I'm also going to create two more random values, so x can remain the same. Basically what I'm going to do here is just copy this and we're going to paste it down here. So I'm going to say y1 and then y2, y1 here and then y2. Okay, and then we're basically just going to add the same thing to y2, so we should end up with two different data sets. Okay, so we'll go ahead and we'll just run that cell. Okay, good stuff. So we've got those. Let's add in a new cell. We now have two completely different sets of data to deal with. So we'll start by plotting the first one. So we'll do plt.plot and we'll do x versus y1. Okay, and then we'll give this a specific appearance. So let's do something like blue x's. Okay, and then we're going to also plot an additional plot. So you can actually do plt.plot again, but it's probably easier just to add it in like this. So you can add in basically one set of data and then the other set of data. So we could do x again because the x values should remain the same. The y values, however, are different, and we want to make sure that we can differentiate between the two. So you know what I'm going to do? I'm going to go for a nice Christmassy kind of feel. So we're going to do green x's here, and we're going to do red dots. So we could do like red O's or something. Okay, and then as per usual, we'll do plt.show. Okay, so let's go ahead and run this. And as you can see, we now have two sets of data plotted on the same graph. Now these are scatter plots again because we're not doing anything with the line. Let's say we did want to actually do the line itself. We can actually just copy this. Maybe I'll start a new cell just to kind of keep that one alive. And let's just do a green line and a red line. Okay. In this way, you could definitely, I mean, this is really messy, but you could, if you had real data, you could definitely put them side by side like this, or rather one on top of the other, and it makes for a very easy comparison, see how the data is similar and how it's different. Now, it's not always the case that we'll want to do this. Sometimes we don't want the data on the same plot. In this example, it's actually very messy and hard to read anything. So what we could do here is have two plots side by side, or one on top of the other. And that would make it easier for us to kind of tell what's going on. For that, we need to create some subplots. So once again, we'll start up a new cell here. And instead of doing plt.plot, we're going to start with actually a plt.subplot. Now, subplot isn't going to be used to graph, like let's say x versus y. The subplot function is going to be used to specify how many subplots we should have in the overarching plot. So what we do here is we do the number of rows, the number of columns, so let's just say row, column, okay, and then the index. All right. So let's say, for example, I wanted 2 rows. So I wanted the graphs one on top of the other. So I do 2 rows, I do only 1 column, and the index is the very first one because that's kind of what, well, we have to start at the first one. And then we go on to specify our information. So then we can do plt.plot. Okay, we'll just do X and Y. And I don't know, we can do red here. All right. And then this is the first one. Now we want to add in our second plot. And actually, you know what? Let's give this guy a title as well. So we're going to do plt.title, and this is going to be graph 1. All right, so we will now add the second one. In fact, weirdly enough, we're actually going to copy the subplot because, again, we want to specify rows and columns, but now we're dealing with a second graph. Okay, so second index here. So now we're going to add the title, graph 2, and actually, you know what? We'll do a y1. And we'll do Y2 there, just so that we have the 2 different ones. We can do red. You know what? I'm kind of messing up here. We could do red here, and then green like this. Okay. And then at the end, we're going to do plt.show. Okay. Now, before we run this, we might want kind of like an overarching title that is going to be used for the entire plot and all the subplots. So for that, we'll do a plt.sup. Title, kind of like super title, and then this will be both of our graphs. Let's just call this graphs. Okay, so let's go ahead and run that. As you can see, we now get the overarching title graphs. We get the title of graph 1, graph 2. I know it's kind of messy, so ideally we'd add some spacing in there, but you can see that the graphs are displayed one on top of the other. So we can do pretty much the same thing if we want them side by side. So let's copy this. We'll start up a new cell, and I'll just demonstrate that. So in this case, if we want them side by side, we actually only have 1 row but 2 columns. Okay, like this. Otherwise, it's pretty much exactly the same. Okay, so again, 1 row, 2 columns like this. It kind of compresses the data just to kind of fit them in side by side, but this might be a cleaner representation than this, depending on what you're going for. So I think the titles and stuff are kind of squished, and that doesn't look great, but this is easier to see the data in this particular case than this. It'd be easier to kind of compare the trends. So here we just have 1 row and 2 columns, or 1 column and 2 rows, but you definitely are not limited to just those numbers. You can have, let's say, a 2x2 plot if you want. You can have 10 plots if you want. Okay, just make sure that you are specifying the corresponding index each time you go to plot something, and each time you have to specify a new set of plotting. Okay, again, subtitle is the super title for the entire plot itself rather than each of just the subplots. Otherwise, you can just kind of specify the title for each subplot like that. Okay, so that is actually pretty much all we wanted to cover here. We're not really going to get into the customization of these, such as the spacing and everything. I'll leave that for you guys to check out yourself. Just know that you can plot multiple things on one plot by doing things like this. Okay, just make sure you specify all of your line 1 attributes and then all of your line 2 attributes. Okay, and we saw the same thing up here just with scatter plots. And then you can either stack your graphs or have multiple columns in a single row, or you can do a combination and have kind of like a graph matrix. Okay, so play around with that a bit, and when you're ready to move on, we will cover some different types of graphs. Okay, so stay tuned for those. Thanks for watching, and we'll see you guys in the next ones. Hey everyone, and welcome to the 6th tutorial in our Pyplot course. Here, and over the next couple of tutorials, we're going to be focusing on different kinds of graphs or charts, and these are going to be some of the more commonly used ones that we might be using to represent data or to kind of examine patterns. So, we'll start with a bar chart here. All we'll do is create and customize a very simple bar chart. For starters, we'll create a separate dataset for this because bar charts are going to be used for categorical data rather than just numerical. We'll work on plotting the dataset on a bar graph or bar chart. The two terms are pretty much interchangeable. And finally, we'll work on customizing that bar graph or bar chart. So let's head on over to the code. All right, so this is where we left off last time. This was number 5. We worked on multiple plots. We can plot multiple lines on a single graph or create multiple subplots. So to start off with, we're going to create a new cell. Okay, zoom in so you guys can see a little better. By the way, you guys don't have to zoom in if you want. If you don't want, this is more for your easy viewing, let's say. Okay, so we'll start by creating new data. Just a heads up, if the datasets look a bit different, that is because I once again had to reset my kernel, so the data is going to be different there. So we'll start by creating some data. I'm just going to call mine bar chart data. Okay, and I'm going to actually set this to be a dictionary. I find a dictionary just makes a bit more sense because we're dealing with categorical data so that we can use the keys for the categories and then the values we assign as the actual values. So bar charts typically represent counts across a couple of different categories. Okay, that's probably the more common place that we would see bar chart data. So I'm feeling a little uncreative. I'm just going to call my categories 1, 2, and 3. Okay, and I'm just going to assign some random numbers to each one. So we'll start off with maybe like a 5. We do 10 here, and I don't know, maybe like 7 or something. Okay, feel free to enter whatever you'd like. If you want to call these categories something else, that's fine. If you want more or less categories, you want different numbers, that's totally cool. It's up to you. Okay, so we have some data. Now in order to plot it, we're going to use plt.bar this time. So this creates a bar chart. As you can see, it takes in an x and a height, takes in a width. This is going to be the width of the actual bars themselves. 0.8 is pretty thick. It actually also adjusts depending on how many categories we have. And then we just have some positioning stuff. So we'll basically ignore all of those except for x and height. Height we can think of as just being the y value, by the way. So for this, we're going to get our bar chart data, and we're going to take the keys. Okay, and just bear with me here a sec. We'll do the same thing, so bar chart data, and then we'll just get the values for the y. Okay, and then at the end, we'll do plt.show to actually display it. Okay, so the keys are going to be our categories. So again, this is going to be what's on the x-axis because that's what bar graphs are for. They show us the different categories and then the counts across those categories. So the counts are going to be the y values or these values here. Okay, and then the x values or the categories are going to be these keys. All right, so let's go ahead and display that. Okay, so pretty cool. A little boring, but that's fine. Our data doesn't really mean anything anyway. You can see our categories named at the bottom. We can see the values at the top, and then we just have the bars that represent the actual numbers. So our first category had 5 members, then 10, then 7, and this would probably be counts of these categories. Okay, so one thing that we might want to do is add the titles and the labels. These are done in exactly the same way. So it's just plt.title, okay, and then we do plt.xlabel and plt.ylabel. Okay, and for each of these, again, we're just going to enter a string. So the title could just be, I don't know, our bar graph. By the way, again, you can call this bar chart if you want. Doesn't really make a difference. Okay, and then we'll just have the category. Okay, and then we'll have the count. Okay, well, we can run that again. So you can see title and then our labels here. Okay, so what about any kind of other customization such as colors or lines or anything like that? Well, we don't necessarily have lines or points. I would say these are bars, so are very slightly different. We saw that we can adjust the width of the bars right in here, so that's fine if you want to do that. The other thing we can do is change the colors of the bars, but it's not like we can necessarily change the styles of the bars like we could with the different lines. So if we want to change a color, what we can actually do is say something like plots is going to be equal to this, and then we can say plt.set P, just like before. We can put in our plots, and then we're going to give, I don't know, maybe a color. We'll do color equal to, I don't know, maybe we'll try red. Okay, R for red, and you can see that changes the bars there. So just like before, we can use any of these different colors that we had in our previous sections, which was up here somewhere. Yeah, here we go. All right. So that is pretty much it for our bar graphs. Again, bar graphs very, very commonly used. It's a great way to represent counts. If the counts are not necessarily related to one another, we'll see in the next one. Pie charts are going to be another way to represent counts, but it's slightly different. This is categorical data typically. We have the labels at the bottom. We can add our title and our axes labels just like before. We can customize the color with set P. Otherwise, it's essentially just graphing our categories on the X and then the numbers on the Y. Okay, so that's it for this one. In the next section, we're going to be covering pie charts, so stay tuned for that. Thanks for watching. See you guys in the next one.